So, I know I've already got one marked down for attending yesterday. I'll let the other one rest it to do in a little bit. All right, I've got the recording underway. I'll see how fast I get through this. It took an hour just a little bit ago when I just did the presentation to the in-person class. So we'll see how it runs through on this. Hopefully it stays within an hour because that's what I've got to do it tomorrow afternoon for the North Carolina group. And y'all are actually going to get the same PowerPoint they're going to get. The PowerPoint, less the title slide on the front and back, is sitting in course documents and Blackboard for you. So if you want to get the PowerPoint and look at it later, you can. The other part is I am recording it, so I'll post that probably this afternoon, tonight. I don't know which, and I'm hoping I'll get it done tonight, because I would rather do it. It's easier to do uploading and downloading from home than here from school. The internet's with their firewall and some of their rules they got set. Sometimes it gets a little tricky on and slow on us trying to upload videos that they tend to block out on. So I am going to start the presentation, and then I'm going to see if I can pull this off to share the screen. Well, it doesn't look like it's going to let me do that. So we're going to see how this works when I try to share the screen in just a second, because if I try to start the PowerPoint first, it sits on both screens and doesn't give me where I can get to the stuff. And hopefully when I just click to share the PowerPoint, that it will get the, when I go to start it, it will actually work. So we will see what happens. So should be getting a screen share, and you should see the, not in show mode, but in the other mode. So I'm going to click into the show mode, and now I've got the problem of, oh, here we go. Now I can see the taskbar again. I forget that's there. And it doesn't look like that changed for y'all. So let me stop the share and try the share again. And it looks like it gives me another screen on it. So show taskbar again, try it again.
It's better.
It looks right now. Okay. So except it's got it on the opposite of the screens than what I really need it. So let's see if we can pull this one off. If I can possibly. Looks like not. Okay. So I can't see y'all's comments. If you put anything in the chat box, it's hidden that from me. I got two screens here and one. I can't get the, wait a minute, maybe I can't. Let me try this one more time. See if I can pull this one other way. I'll try this. Nope, it don't let me. I can't get it to switch screens for me to get it so that I've got Blackboard on one screen, Collaborate on one screen, and got the actual showing on the opposite screen. So if y'all have a comment to me, I know Todd can talk to me, that he's got microphone. I don't know if Maya does either, but Todd, if you see Maya pop something into comments, let me know.
Yes, sir.
Okay, so that'll work. All right, so we're looking at IP version 4 subnetting. Several big things on it that we're going to deal with. We're going to borrow bits from the host byte, so that's the rightmost byte. And actually, y'all can borrow from more than one byte, but we're not going to worry about that. We're just going to assume you're just can borrow from one byte. And so we'll be borrowing bits from the host byte, which is the rightmost byte. Okay, because the network ones, remember, are sitting on the left, so we're borrowing from the host. First thing we're going to do is change that byte or octet to binary. And that's wrong. Yeah, okay. The leftmost host byte, that's correct. So of the host bytes, we're going to be using the leftmost one of the host bytes. So if there's more than one host octet or host byte, we use the leftmost one of those. But we're coming from over on the right side of the whole address. Maybe it'll make a little more sense once we get to the next screen or two when we actually have. And then we're going to leave the network bytes just like they were, or octets. So the network ones are going to stay as they were. So we're not changing the network stuff. We're only fooling with a host byte. And that first you have to determine the number of bits that you're going to borrow. And there's two different calculations on this, and we're going to go through both of these. One is if you know the number of subnets that you need, then we're going to number from the left when we're looking at that byte. And that's what I'm going to show you first. And we're going to actually end up doing our binary number, column numbers, reversed from how you learned them when we went through binary a few weeks ago. That's only for determining the number of bits to borrow. But that will get us the number of columns that we're going to borrow or number of bits that we're going to borrow. Columns or bits, whatever you want to look at. If you know the largest number of subnets on a the largest number of subnets that you want. So that was, wait a minute. If you know the largest number of hosts, then you number from the right. That is an error right there, and that needed fixing. And I missed that one again. I'll have to fix that when I get off. So if you know the largest number of subnets, then you number from the right, which is just like your usual. And bytes misspelled there too. Oh, well, I missed those just a little bit ago. So if you know the number of subnets, you number from the left. If you know the number of hosts, you number from the right. And I'm going to go through both of those in just a second. On a certification exam, you may be asked what the starting address is on subnet 3 or the broadcast address on subnet 4 and so on. You only need to build the table that we're going to be looking at as far as it's needed. So when they're saying about on subnet 3 or subnet 1 or subnet 2, you only need to do calculations for that many subnets. You don't have to build the whole table, which could be a bunch of subnets. You just have to build as far as you need to find the answer that you need to answer the question. That's just a hint for certification purposes. Well, actually for your test purpose too, it could bump into that too. So now we're going to go with that we've been given the number of subnets. So we know how many subnets we want, and then we'll find out how many hosts we can have per subnet. So the example I'm going to use here is 192.168.1.0. And remember, that's a private address, which is always used in examples. So I'm going with that one that we're using. We want 8 subnets. So for that network address, the subnet mask or the network mask is 255.255.255.0. That should be 3 255s. That's a tongue twister just about. Okay. And the last byte is the host byte. The first 3 octets or bytes are network. So if we take that last byte, convert it to binary, it then becomes 8 zeros. And then what we're going to do is we're going to number from the left on our columns, same as we did when we learned how to work with binary numbers working from the right, but in this one situation, and this is only for this, we will number from the left. So there I've got on the next line the the column values, which starts 1, the 2s, the 4s, the 8s on the column. Okay, and that we want, and that one of the factors will be into play on that is whether you can use the 0 network. Well, I'm going to go ahead and borrow 4 bits, which will definitely cover our 8. It'll actually give us 15 subnets. You do always want to borrow more so that you've got group, so that if we needed 8 subnets, yeah, we could get by right here with just borrowing 3, and that would give us the 8 subnets. But if we need to add another subnet later on, that we'll have to go back and readdress our whole network. Okay, so you'd want to have some extra ones. Remember, in the host portion, all zeros is the network address, and all ones, and that's both binary, is the broadcast address. So we're going to borrow 4 bits to make sure that we've got more than 8. Most of the time now you do get to use the 0 subnet. Certification questions I always see on that have something like this will tell you if you can use the 0 subnet or not, because that becomes significant about knowing which, when they say something about the 3rd subnet, well, you got to know, is the 0 subnet count or not? Normally it does, and I always see them telling us, but Cisco equipment really does use it. So now so our subnet mask now in this case will actually be 255.255.240. Well, where do we get that 240 from? We're now going to borrow the first 4 bits. So we'll put 1s in there for the subnet mask. So that's 4 1s followed by 4 zeros. And then I've got the column values under there, which have been numbered from the right like normal. So this is back to how we're working with binary numbers correctly. We only did the working from left purely to figure out how many bits to borrow. So we've got the 128s, the 64 column, the 32 column, and the 16 column. And then it would be 8, 4, 2s, and 1s. And so we add up the column values, and that's 128 plus 64 plus 32 plus 16, which gives us 240. Now, the other part for you there is the very last 2 bits cannot be borrowed. They have to be host bits. Okay, so you can't borrow all of the bits in the host. You have to leave the last 2 bits of the whole thing there, because with 2 bits, that will give you 2 hosts. Because you've got a broadcast address and a network address, and there's a total of 4 possible there, but you're using up 2 of them there, so that's only 2 usable hosts. Okay, because 00 would go to network address, 01 and 10 would go to host addresses, and 11 would go to broadcast address. So just remember, you can't borrow the last 2 positions. Okay. Whoops. No, I didn't skip anything. The mouse jumps for me. So now we're going to build this table here, and that's what I'm setting up here. So our IP address is 192.168.1.0. Our subnet mask for the network, so our network mask is 255.255.255.0. Our subnet mask for each of the subnets is going to be 255.255.255.240. And then the last byte is what we're going to actually be doing work in. Okay, and so in our chart here, we're only going to put information about the last byte, and in front of everything we put in there will actually be 192.168.1. Okay, because the last byte's the only thing that changes. So now we'll go on to the next slide. and we'll start building our chart. So the first thing that will go in here is I've got it labeled as binary, the first column. Sometimes I label it as binary, sometimes I label it as network. Actually, I seem to really label it as network more, but when I did this presentation last fall for CompTIA, I called it binary for some reason. So it's actually the network address, okay? So that I got it that way for some reason. So the first one, we're on the first subnet, so I've got 1 right there for the first subnet, and then its address is going to be 4 zeros in the network portion, because that's the first one, and we said we could use the 0 subnet. And then the host portion will be all zeros because it's the network address, which converts to a decimal 0. The beginning of the range of usable host will start from the first one. So it will still be, the network will be 4 zeros, and I'm putting the network in bold in all of these slides, and then the host in not bolded. It will have 0, 0, 0, and the first number of 1. So it starts from 1, and that actually in this case converts to a 1. So here's my explanation going through it. Except for some reason I told you about 3 instead of 4 bits as I did my explanation. I'm not sure why I did, but it's still the same thing. And then our largest host one will actually be 1110 in our case. The way I'm describing right here on the screen says 110, but we would have one more because we've got 4 bits there for the host still. And that's 1 less than 111. And remember, that's in binary and really doesn't make any difference which one you look at. 111 minus 1 is going to give you 110. So our highest host will be, in our case, 11110. That's 3 ones and a 0. And the lowest will be 0001. Y'all can see why you really don't want to do this stuff all in pure binary. So we end up with this as our first row on our table. So all of them, notice, have the same network address of the network bits. They're all zeros, 4 zeros in every example. And for a moment there, I thought I was seeing extra 1s. And then the network address is all zeros. The beginning range, the first position on it's 1 higher than the network, so that's 1. The ending is 1 less than the highest, which is the broadcast, so it ends up being 1110, which is a 14. And the broadcast is all 1s in the host portion, so that's 15 because there's nothing in the network portion. Have I got any questions at this point?
No. And this is the way I did it normally. Network, first host, last host, broadcast.
Yeah.
So that's how I've done it.
It's the same.
3 years.
How you label the columns, and I say,
Yeah.
I'm not sure why I've got binary up there instead of network. I may go back and change that before I do it. But for some reason I stuck binary up there. Network's what I normally seem to put right there.
A lot of people put subnet too.
Or subnet, yeah, I may put subnet there. And then it's the beginning range and the ending range for the host addresses. So, and then the broadcast address. So now to build the next subnet, we'll add a binary 1 to the borrow portion, that's the network portion. So now, since we're borrowing 4 bits, we'll add 1 to the first 4 bits. So that becomes 0001. And then for the first column of the network portion, it's all zeros in the host portion. So we end up now there with these numbers, 0001, followed by 4 zeros, and that converts to a decimal 16. So in parentheses is always these decimal numbers as I build these charts through. And then for the first host address is that we're putting a 1 into the host, we're adding 1 to the 0. And so we end up with a 0, 0, 0, 1, 0, 0, 0, 1. And that converts to 17 because it's a 1 in the ones and a 1 in the 16. And so we've got that as the beginning one on this. So we're on subnet 2 and we've gotten that far. So now then we do the maximum for the host area, and that's less 1 than if you had all binary 1s in there. So that would be 3 1s and a 0. And so we end up there with 0, 0, 0, 1, 1, 1, 1, 1, 0. And that converts to a decimal 30. And then for the broadcast address, we're going to do the same thing, except we'll have 4 1s there in the host area. So it works out like this to get a 31 there. It's all binary 1s in the host area, but our network area stays constant all the way across on this network, because for this subnet, it is 0, 0, 0, 1. So this is 31. So we get that number. Now, the next one, we'll build the third subnet. And remember that the network portion is using the 4 bits. So now we're building the next network. So we've used it 4 zeros, then we did 0, 0, 0, 1. And if we add 1 to that, that would become 0, 0, 1, 0, because we know it's the 1s, the 2s. So a 1 in the 2s column would be equivalent to a 2. Although when we look at the whole address, we're really not counting only the first 4 bits. And so we build the whole line out across there exactly the same way we did before. So we've got a 0, 0, 1, 0, and all zeros in the network portion, so that's 32. We put a 1 in the host portion for the first host address, which would be 33. And then the highest one would be, again, all 1s minus 1 in the host portion. So that would be the 0, 0, 1, 0, 1, 1, 1, 1, 0, which is a 46. And then in the broadcast portion, it's all 1s in the host portion, and the network has stayed constant all the way across the line. Now for the fourth subnet.
Wouldn't it be for the second subnet? Because what you're doing is you're adding 8 to the total, because each block size is 8. So it's 8, 16, 24, 32, right? So for the third subnet, it would be 24 instead of 32. You would have a 16th place and an 8th place. No? Okay.
16s.
So it's 16s?
That's correct on there.
Not 8s. Okay. Oh, because we're going up 1 because we're adding subnets. Yep, for expansion. Okay, I'm with you. Sorry.
In just a second, that'll make a match into something I'm getting ready to cover in just a minute.
Yep.
Okay. Gotcha. But they are 16s on there. Okay.
Yep.
Because we're working over in the black bolded area, remember?
Yes.
So when we moved, and so that's the 16s column there. Remember, it's the first of the bolded area.
Yeah.
Because the host area is 1, 2, 4, 8. And then the bolded area starts with 16, 32. So that'll go by 16s.
Good.
In this example.
Nice.
Then for the next one, it would be 0, 0, 1, 1, which means we got a 1 in the 16s and a 1 in the 32s, which would be 48. And then we do the others equivalent. Now, I'm not going to build this all the way down, but I'm going to run down to where I run out of space on the bottom of the PowerPoint slides. So then the fifth one is 0, 1, 0, 0, because 1 added to 1, 1 becomes 1, 0, 0. Because remember back in binary that 1 is our biggest number, and you add 1 to the biggest number in any number system, you always get 0 and carry the 1. So 1 to 11 in binary would be 1 plus 1 is 0, carry the 1, which then makes it 1 plus 1 is 0, carry the 1, which means then 1 and 0 is 1, and so it becomes 0, 1, 0, 0 on how we're doing it. But you can always sit there and just calculate back of adding columns up to get it correctly too. So we get that row there. They've all gone across there, and we got our ranges and our usable addresses in there. And so notice we got 14 usable addresses on each line for each subnet. And then we'll do the sixth one, and it's 0101, and it builds across there. And remember, this is the sixth subnet, but if you add the value of just those 4 columns, that's the network, it's a value of 5, because remember, we're using all zeros as a subnet also. So this really is the sixth one down there, even though the value is a 5 in the column there. Where I've mentioned before about a lot of things on computers, the first thing is 0. And then the 7th one, which is the last one we're going to do on here, it's not the last one on this subnet, but it's the last one we'll mention, is 110, and you build a chart across on it. Now, where Todd tried to get ahead of me, or wait a minute, we got the 8th one. I'm sorry, we're building the 8th one. I forgot to build the 8th one. That it will be 0, 1, 1, 1, 1. 3 ones in any event. And we got that, and that's as many as I can get on one page in that size font on it. So we're going to pause on this one there. You can see how they continue to build. But we've gone through looking at how to build all of these. And remember, the first thing I told you is if they're asking you about something on the 3rd subnet, you only need to go as far as the 3rd line to do that question. If it's on a cert exam or on the test, you don't need to build the whole thing. Just build as far as you need to go to find the right answer. That'll save you a bunch of time right there and aggravation, etc. The other part is, so there's actually still 6 more subnets we could build on down that table. So what I want you to look at that table, and forget that part about put it in chat. That was dealing with how I was doing that one on it. Look at the table again and see if you see a pattern in it between all of those numbers on the whole table. When I took this, learned this in the first Cisco class, the instructor hadn't, and I saw it as we were doing it, and then the other students went, oh, once I explained and went, oh, I can fill out this table real fast after we did the beginning of the 2nd row. What happens on that whole thing? Anybody see a pattern to it?
I see even odd, even odd.
What were you commenting on a minute ago, Todd? And Maya, if you see it, stick it in chat and tell
Todd.
Tell Todd to tell me. Assuming you don't have a microphone.
It would be the block size. It increases, everything increases by 16.
16. That everything down that chart, the decimal numbers, once you got the first row and the first number on the 2nd row of it, numbers calculated, everything else can be calculated real quickly there of the decimal numbers, which is what we really want. We're really not worried about the binary. We're needing the binary to be able to find the decimal numbers, but we really don't want the binary any further than that, okay? You've got the whole rest of the chart produced by just adding 16s all the way down each row, each column, I mean. Just run down the column, everything increases by 16 all the way down it, okay? So all you have to do is get to that first value on the 2nd row and see how much what its value is, and that gives you the key to filling out the whole rest of the chart there. And that you don't have to sit there and do all of that binary work that we just walked through. And that's a whole lot faster and shorter to me. Now, if that doesn't make sense to you, but the other does, you can do the other. I say, the guy that was teaching my class and the other students that were in the class, that's all they were thinking on it. And I was sitting there and went, whoa, I see a shortcut to do this thing a whole lot faster and I spew off answers, even though I really hadn't understood the stuff right before I walked in class, but I could spew off answers really, really quick. So the pattern 16, and that you can do them all on that. So to me, that's a tip to dealing with it when you're on tests and stuff, even when you're out there working in the field and you go to do it. There's your whole thing to be able to produce the stuff quickly for yourself. So now let's go the opposite direction. Unless y'all got another question for me where we're working with it from knowing how many subnets we wanted. Now we're going to go with the approach of we know what's the maximum number of hosts we want on a subnet. And you could be given either value, okay? That you could be told, okay, the most hosts that we'll have on a subnet is this number, or we need this many subnets. So you might have to calculate one or the other direction. So I've already shown you how to do it with subnets. Now I'm going to show it to you that you're given it with number of hosts. In this case, we're going to go with that you've been told that you need at least 17 hosts on one of the subnets. Maybe more than one of them, but the most of any of the subnets will be that they need 17 hosts on a subnet. Because of the way subnetting works, you have to make every subnet big enough to handle whatever the biggest one's going to be, okay, because they're all equal size. At the very end of the lecture, I'll show you something different on that. But basic subnetting, they're all the same size. So we're going to go with a different network address this time. It really doesn't make any difference to us, but we'll use 10.10.2.0, which again is a private address, is a class A address. And that actually we had been given that as the network address. So the subnet mask for that network we were given to work with is 255.255.255.0. If we were looking at it purely from a class A address we were given, it would just be the 10. So our subnet mask would actually be 255.0.0.0. But in any event, we're going to work with the last byte anyway on it, which is where our host numbers are. So we've already apparently subnetted our network some, and now we're subnetting it further, okay? And so we look at our columns. In this case, we number them from the right. So this is like we're used to. This is how binary really works. So we'll start numbering from the right and go to 1, 2, 4, 8 until we get up that will be big enough to handle 17 hosts. So we get up to 16. And we know with 16, the next one will be 32, which is bigger than the 17. So we know that going through the 16 will give us enough to have, okay? It'll actually give us where we'll allow that we'll have 30 hosts per subnet available, which is important, particularly doing it from this direction, because I can guarantee you on any of the subnets, they're going to need more host addresses on down the road, because there's all kinds of additional things coming up with that need network addresses. And if you just made it exactly to the size of the number of hosts that they have now, that you'd have a problem. But we got to allow extra anyway in this case, because 17, if we had 16, we'd actually be able to get by, drop it down one, okay? But since we need 17, we got to go up. Actually at 14, we would be able to get by with one less, but since we got more than 14, we got to go to this next position. So we've got growth on there. So we're going to have 3 bits available for the subnets. So that will allow us 7 or 8 subnets, depending on how it works on it. But you don't ever bump into the top one normally. So our subnet mask will be, for each of our subnets, 255.255.224, because that's using the first 3 bits for the subnet, which is in the 128, the 64, and the 32 columns. And then that adds up to 224. And just as a little reminder down there, again, you can't borrow the last 2 bits, although you're really not going to have that issue on when you're going from the network side, because you'll leave from the number of host side, because you'll leave at least some bits there for the host as you start counting up. So now we're going to build the same table again. Looks exactly the same as we had before, except to change the IP address up there. It'll look a little different. But we're just going to build on the last byte again, just like we did before. And So that numbers will be replacing the 0 up there in the 10.10.2.0. We'll pull numbers from down in our table down here. And so we'll start building the table all over again. So the first 3 bits is the network. So I bold those again in our illustrations here. And that the unbolded portion is the host portion. So again, I'll build exactly like we did the other one. The network, or as I've got it labeled as binary, will be all zeros in the host portion. So that will be a 0 then for this first subnet, and that we're using the subnet 0. And then the first usable address, and now notice I've got it up there as usable host right above there. Makes a little more sense to it probably. The beginning spot on it is that we will put a binary 1 there in the ones column, so that's 1. The ending position will be the all ones in the host portion less 1. So it's going to be 1 1 1 1 0, because that's 1 1 1 1 1 minus 1 gives us that number. So our largest is going to be the 4 ones and a 0. So we end up there, and so 30 is our highest one, and 31 will be our broadcast. And I forgot to put the phone on vibrate. Sorry about that. So then we'll build the next subnet, and we'll add 1 to the borrowed network portion. And so that becomes 0 0 1, because remember we're borrowing 3 bits. I'm holding up my fingers like y'all see that, but well, I guess you do, because you do see my picture still of me in small on it. But so it will become the 0 0 1 and then all zeros in the binary. So we end up with that, which is a 32. Now, with what I already told you on the other, you now know what you can do to finish filling out the whole chart. That they will go by 32s now. Okay. Did I do the other chart correctly? I'm scared to look back real quick. Sorry, I'm going to do this because. Okay, we borrowed 4 bits back then too, although I talked like it was 3. We're borrowing 3 here, but we went up by 32s back there, didn't we? No, we went up by 16.
16.
It was right. Okay, never mind.
Yeah, you're good.
I just confused myself. Sorry about that, y'all. But better to look and make sure.
Okay.
So it goes up by 32s because that 1's in the 32s column. So now we know the key to this whole chart is 32. And so now I'm going to be able to go ahead, and I know that we're going to add, and here's another typo I failed to fix, and I saw this one earlier. We'll increase the byte, not the by. It's not the end of the lecture quite yet, by 1. And that becomes 33 in the first usable host. And then we'll increase the next one. It'll be similar setup with the 0 0 1. And then we'll get the ending range by all ones minus 1 in the host portion. And so that becomes 62. The other part to notice right here too is that the network is always an even number. Broadcast is always an odd number, and your range ranges from an odd to an even number. That one I notice sometimes too on it, just as another one to give you just an indication if you goof up somewhere. And then the broadcast will obviously be the 0 0 1 and all binary 1s, which would be a 63. And so there's the second subnet. And then the third one that we would build it similar with 0 0 1 becomes a 0 1 0, because if we were just looking at those 3 columns, that would be a 1 and a 2s. So we've done the 0, the 1, and the 2. That's what we're doing. And poof, it's there. Because effectively, we added 32 to everything from the previous one. And then for the next one, we'll add 32 for the fourth one. And we get all our numbers across there. The fifth one, add 32 to it again. We're adding 1 to the previous subnet number. And we got all of the numbers across there. And then the sixth one, the same thing. The seventh one, the same type thing. And if I flip too fast on this and you want to go back and look at it again a little more in detail, reminder, it is sitting in course documents.
Okay.
And if I get corrections, I'll fix those corrections in there too. And then the seventh one, and then the eighth, and that's all we need to know at this point. So you've seen how to build it if you know the number of hosts and if you know the number of subnets that you need to use. Any questions on that? That's basic subnetting. And remember on these, every subnet is the same size in whichever exercise you're doing of it. Then the last thing, and the book spends about 3/4 of a page on it. This has become less emphasized. If you took this class from me 2 years ago, just a lot more emphasis on VLSM, but it's just basically mentioned here, and they don't even have you doing it. But I'm going to show you what it is, but tell you first what in the world it is. Variable length subnet mask. With this, we can set up subnets that have different number of hosts on them, okay? And that way we don't, for instance, when you connect a router to a router, that subnet only needs 2 host addresses on. That's all it can use. But with the way we just did, if you set it up, you would have to make them all that small, but that wouldn't be the case, that your network would have different ones, and that you end up with a lot of wasted addresses that you just can't use and won't use. So with VLSM, it's to make it more efficient. And what you're going to do is you're going to subnet first for the largest number of hosts, and you'll have 1 extra subnet. Then you'll subnet that extra subnet for the next size of host, and then you'll so on down with creating an extra subnet each time, 1 more than you need, and using the last one of them to subnet into smaller number of hosts per subnet. And so you increase your efficiency on it. And so that's the whole idea of variable length subnet masking, is that you're going to be able to make them more to the sizes they need to be, and your subnet mask will actually vary according to which one of those subnets it is, which level you've subnetted. When you subnet the subnet again, the subnet mask changes. So I'm going to show you, so I'm giving you mention here as an example. Usually you got more than just 2 subnets, but I just used 2 as the example. That you got one subnet needs 65 hosts, and you need a second subnet needs only 2 hosts, which may be router to router. That's usually the case. And so you first create 2 subnets that can handle at least 65 hosts in each. So the first one will be for handling that first subnet that we needed. And then we'll take that second subnet and we'll subnet it out to subnets with 2 hosts in every subnet, and we'll end up creating a ton of subnets. So, but exactly what we're doing here, don't worry about, you won't get asked that. But you will be asked about what is VLSM and about that you can subnet to a subnet. But remember, what you already know works perfectly fine for here. You're just subnetting a subnet that you're not using and making it into more subnets within the subnet. So in this case, I'm going to use a 192.168.3.0 address. And because we need 65 hosts, we're going to number off, and we're going to find that we're going to borrow 1 bit for subnets to be able to make the 2 subnets. So you got to remember always, you got to keep 2 bits for hosts. But for borrowing purposes, you can borrow just 1 bit to do subnets, because 1 bit will allow you to have 2 subnets. And then you end up with this whole chart here. And this is actually the last slide before the thank you on it. So the top part of it is where we split it into the 2 subnets.
Yeah.
And so we got a 0 and a 1 subnet, just borrowing just that 1 bit. and the range across there used on it. So we're going to use that first one for the real stuff of where we got 65 devices goes on to. But notice we've really got 126 addresses available to them there. And then the second one, we're going to split it up and we'll use the subnets is what we'll actually assign out to devices. So then I've got the first three of them shown to you right there, that the first one would have the ones carried down because it is using subnet 1, and then we borrowed the next 5 bits, and I've got them in a little bit different gray there, if you notice, showing that they're the borrowed from the borrowed. And so the first one of them would be 5 zeros. The second subnet of them would be the 4 zeros and a 1. The third one with the 3 zeros, 1 0. But they all got the 1 in front because they're all part of that one subnet. And then it builds on across there on it. And notice on each one of them, they've got 2 hosts. The first one has address 129 and 130. And for those subnets, our subnet mask is 255.255.255.192. Now, for that very first subnet, before we subnetted the second one, its subnet mask is 255.255.255.128. I think I did 3 255s. Y'all see on that? So notice that's where it's the variable length subnet masking. The subnet mask have got variable numbers, and that the length of how much we're using for the subnetting varies. For that first part, it was just 1 bit borrowed, and then we borrowed 5 more bits. So we got a total of 6 bits borrowed, but we're borrowing 1 for the first part and then borrowing 5 more bits for the second part. Does that give y'all a basic little idea of what VLSM is? But don't worry about trying to do this chart like I got right here. You're really not getting into that onto your test on it. And even I don't think I know the Network Plus doesn't get down to that level, but Network Plus does ask you could ask you in terms of what is VLSM and about it having subnets of subnets. And I doubt if CCNA does either, but I haven't taken a CCNA test from way back. And then you did have to do VLSM for it back then. But since they've taken it away in the book to just a brief description, and we're moving to IP version 6, which is next chapter, you really don't have to know much about it, but you need to be well aware of it. So the next slide is the thank you slide. That doesn't say thank you, but gives you my information because I'm going to be speaking to all strangers tomorrow afternoon with this one. So y'all got questions for me on that before I stop sharing?
No, it's good. So basically, VLSM is just subnetting a subnet.
That's exactly what it is.
So normally, would you use like 65, or if you're going to subnet something, because you said start at the top, so 65, it's going to give us, the 128. So then we would just take that if we needed, let's say, I don't know, because you're saying we only need three subnets for 4 IP addresses for 3 separate router connections, basically. We would just take that. Let's say we needed 16 IP addresses. We would take that second subnet and subnet to the point of 16.
And so you'd end up with several different subnets of those that would each have 16. And then if you were also going to do a router-to-router connection,
you would subnet one of those last ones.
What subnet the last one of them that you're not using and create it smaller to get your different router-to-router connections to go on those.
That's cool. Okay. Yeah, that's great. Thank you.
Let me look back here. Yeah. So
I've seen it. Go ahead.
So that's where you do use it on when you're just going to do that when you've got usually a real large network and that you're wanting to get a number of subnets within. So for instance, a school, if they were going to run all of the campuses all together on the same network, we could do each one of them, each of the campuses submit it, and then break it apart even further than that. Okay.
Yep.
So, and obviously the campus sizes all vary, so we could very well set it up slightly different for them all. So that's subnetting.
Yeah.
All right, let me stop the share. Did I stop the share?
Yep, you
All
stopped
right.
to share.
Yeah, I had
but
stopped
you're
the
still
share, but I
recording.
was still looking at the slideshow. All right. Let me see. I don't see anything in chat. So y'all got any question? Maya, you got any questions for me?
No, thank you.
Okay. Oh, so you got a microphone the whole time you could talk to me also. Okay. I never know who has a microphone.
I thought it was on, but I just now looked at it and it was off.
Well, that's okay. When I did the recording in class this morning, because you have to first enable, and then for on it when I go to do that, I have to turn around and then share the microphone or camera, or one way or the other. That you have to do twice, tell it to use the microphone and camera. And I started into the lecture, and the student that's sitting by the computer that I'm using to do that said, it's the microphone's not working. Walked over and I looked, and I went, no wonder it's still not microphone or camera turned on, because we had a problem with the microphone on one of the cameras I was using, the newest one and best one that school had bought, but the microphone doesn't consistently work. And so he watches for me, the guy that sits beside it, and went, oh, I just forgot to turn them on. And so then I turned it on at that point. So I had been shooting just black, no noise video for a few minutes. So that happens. Okay. If y'all don't have any other things, I told you it was going to take close to an hour to get through that.
Good.
And it took us right about 50 minutes to get through it. So that's right on what I need to do tomorrow. So once I make these corrections, I'll try to upload the corrected PowerPoint out there into your stuff out there. But you've seen enough and heard enough on it that you could go back through the one I had and realize where just a couple of errors were that weren't that big of things.
No, that's fine.
So if not any questions, I will let y'all go. I will get the grades posted in place of discussion, where you get 100 on the discussion this week. Hopefully on this afternoon, because that's only one grade I got to post on it, because Todd sat through this yesterday, so I already marked his. And then hopefully some others will watch it. So I'm going to stop the recording.
Okay.